so the power problems are pretty straightforward. I think you can do them. F times V. Maybe we'll put in some biological ones because it's fun and you're interested in it. Okay. So we had 3 topics left for energy. One was power. The next one is I promised you, and I don't like to break my promises, I promised you we would get to another kind of collision once we knew that energy was conserved, right? So there's elastic collisions. Okay, so remember back when we did momentum, and we thought about when we ram things into each other and what happens, and you have momentum before, momentum after, and we only did the special kind where they stick together because we had one equation, momentum conservation, and 2 unknowns, how fast each of them are going, and we couldn't deal with that at the time. But now we have 2 equations because we have conservation of energy. Right? So let's just set this up. Let's say we got 2 things that are going to crash into each other. M1 is going at V1I, and M2 is still. So it's not moving. We're just going to do the case where M2 is not moving. You're welcome. Okay? When you let M2 move, it's still the same ideas. It's just the algebra is really long. So we don't want to do it. So when we're done here, then they collide. And I always draw the colliding part like, woo, like that. And then M1 is moving at V1 final, but M2 clearly has to be moving forward as well. Or maybe M1 would bounce back. But in general, there's some V1 final. Okay? So all we got to do is set this up and conserve momentum. We know we have to conserve momentum, and we have to conserve energy. And specifically kinetic energy. We're not giving any mechanism for potential energy here. Right? So this is good review for the exam. How do we conserve momentum? We say the momentum and the initial equals the momentum final. Right? So M1 V1I initial must equal the sum of these 2 momentums. M1 V1F plus M2 V2F. So there's an equation. And you can see now we're back to having 2 unknowns. We didn't make them stick together. We said it's 2 objects that could be going at 2 different velocities. So that's our 2 unknowns. But here we have to the rescue coming kinetic energy conservation. 1/2 M1 V1I squared equals, that's the initial kinetic energy, equals these 2. 1/2 M1 V1F squared plus 1/2 M2 V2F squared. So all you got to do is solve that for the 2 unknowns, V1F and V2F. Okay? And it is so hard if you don't know the trick. I have the trick right here. I could say you guys have the rest of the class to solve this. And you would just go in algebraic circles. Like you would never get there. I mean, you would look it up and do it, right? But if you just start plugging and say, well, I'll solve this for V1F, and I'll plug it in here, and then I'll have 2 terms, and I'll FOIL it, and suddenly this will have 9 terms, and then I'll stick this here, and then I'll be up to 27 terms, and then we'll just all be crying, okay? So there is a trick. So I don't know what the point of doing the trick is. There is a trick. Now let's do the trick. I guess what I want you to see is that sometimes when you have simple equations, it's just because of mathematical luck. It's not that there's anything deep about this. So let me show you the trick real quick. Maybe we won't do the whole thing. We'll get it started. What we're going to do is rearrange the K equation, right? In case you become theoretical physicists. Here, I'm teaching you some methods here, right? So when you look at this, you see a bunch of squared terms. You don't want to stick these in here, right? Because that leads to messes. You have the sum of 2 things and you square it, it makes a mess. What you want to do is get down to less terms. You want to write them in simpler ways. How could you get rid of squares? There's one mathematical rule you learned, probably you guys learned it in 3rd grade, that involves squares. And you want to get rid of these squares. It's not a lathe. Thank you. Machine shop guys? Anyone? No. And gals? No. Okay. Squares. What's the difference of 2 squares? The difference of 2. Yes, thank you. The difference of 2 squares. So what we could do is rearrange it and say, here we have M1 V1I squared, and here we have M1 V1F squared. Ooh, what if we did this? First, let's get rid of the half. Okay, very good. We could say M1 and pull this one over here, and now we have V1I squared minus v1f squared. Ooh, badass. And then we say m2 v2f squared. Okay, it's not necessarily simpler yet. We're getting there. But wait, what is this? This is the difference of two squares. This is equal to m1 times v1i minus, we'll do the plus first, plus v1f times v1i minus v1f. So anybody remember that? When you FOIL that, the cross term goes away. Right? So now the squares are gone. Oh, this one's still here. Equals m2 v2f squared. Okay, so this derivation you don't need. You just need the answer. But it's so much fun that I want us to do it together. And there's a good chance I'll mess it up, and that'll be fun for you. Okay, let's see. All right, so now what are we going to do? Now we're going to come back up here to momentum and say, I bet you I could get something that looks like v1i minus v1f. Right? I could get m times v1i minus v1f by pulling those to the left. Is that how I wanted to do it? Oh, no, I did it a different way. Forget about that. I bet you I could solve this for v2f, right, and stick it right there. And that's going to have v1i minus v1f in it. That's going to cancel that one. Wow. We are like at the pinnacle of theoretical physics right now, okay? M1, this is what they do 50 years ago. v1i plus v1f. Now they just play Doom and say that they're working. v1i minus v1f. I'm sorry, not Doom. Something else. Okay, so there's the left side. And now for the right side, I'm going to say m2, and then we're going to say v2f squared. But v2f is this over here, 1 over m2. No, I'm sorry, it equals m2 times, so what am I doing? Oh, we want to plug in for v2. We got to get this squared, right? So we're going to bring this over here, pull out the m, pull the m2 under it, and square the whole freaking thing, right? So m2. So we ended up with an m1 over m2 squared. Right? That was the m parts like that, and then v1f minus v2f squared. That's what we got to do. What a mess. Look at the big, beautiful mess. What can we do now? v1f. Oh, wait, that's not right. They're both v1s, right? Let's see. So v1i minus v1f. That's what it is. Sorry. v1i minus v1f. I had it completely wrong. Minus v1f, right? Because the point is that will cancel this one. And now there's no squares anymore. All the squares are gone, just by this lucky thing that happens when you do the difference of two squares. Look at that. Let's not finish it. Okay, now it's just algebra. But I wanted you to see the fundamental mathematical trick. That was the mathematical trick. So we will take our break, and we come back, and we'll just give you the answer, and we'll get on with our lives. But that was the trick. Very exciting.